Hello, can you hear my audio? Oh, all right. Okay. All right. So Orange Book, I'm hearing I got 14, 22, 32. Okay. Oh yeah. Sorry, Eric. Yeah, I'll post those right after the stream. I'll post the notes I'm doing now plus what we did period 1, 5, and 7. 1, 2, 5, 7. Okay. 14, 22, and 32. Okay. Just a moment. Okay. So number 14 is a little bit different. They give you a volume of an open top cylinder. So you have yourself a cylinder here in number 14. It has no top on the question. It's got no top. And what they tell you in the question, what they ask you to do is it says find the ratio of the height to the radius that gives minimum surface area. So the surface area of this function would be same thing. You want to calculate the area of the bottom here. It has no top, they said, so we have a fixed radius on this. Let's call it radius r. I can give this a height h. So the radius is going to, you're going to get, the surface area is going to be pi r squared. Because it's open top, there's just the bottom that we're talking about here. And then you have, when you unravel this shape, you're going to get yourself a rectangle. And as you know, this is going to be 2 pi r for the circumference, and this will be h. So this will be plus 2 pi r h. Right, so this becomes our surface area function. So what they want here is you're not given the volume. Like normally you're given a numerical value for the volume, but you know the volume of a cylinder is pi r squared h. So that implies that h is v over pi r squared. So what I can do here is I can get rid of the h and I can write it as a function of v over pi r squared, where v is a constant term, like it's a fixed constant term. So now you have your surface area r expressed as pi r squared plus 2. The pi's will cancel. I'll get pi will cancel, r will cancel, 2v over r. So that becomes my surface area function. So who had asked this one, the idea here is normally you're given the volume itself, like you have like a number for the volume. So I just treat it as a number and I sub it in. You're just looking to find the dimensions that give you minimum surface area if it's this is an open top cylinder. They just say find the ratio of the height to the radius. So let's treat it like a normal question. Take your derivative like a normal problem. I'm going to get 2 pi r minus 2v over r squared. Yes, thank you. And then you're going to set this equal to 0. And I can solve. So 2 pi r minus 2v over r squared. So this is 2v over r. So I'm just solving this I realize that they want the ratio of h over r, which I think we can figure out later using this. So what I did with number 14 is I have my formula here for volume. I isolated for h and I subbed it into my normal surface area formula. Notice here I don't have a 2 in front because it's an open top cylinder. And then I went ahead and just took my derivative, treating v as a constant term. And then I solve for r. So if I solve for r here, I get what? 2v equals 2 pi r cubed. So in this case here, r cubed is going to equal v over pi. In other words, r is going to be the cube root of v over pi. So I get my radius is equal to the cube root of v over pi. So that doesn't answer the question. They want the ratio of h over r. So the only, I have this formula here. Like I have another equation that involves all of these letters. So what I'm going to do is I'm going to sub in the r. Right, so I'm going to look, actually not going to sub in the r, but if I take h over r, that's going to be h is equal to v over pi r squared. And r I just found is the cube root of v over pi. So if I do this, does this help us at all? H is v over pi r squared, that works. Yeah, I can do those for sure. Just give me a second. This should work out here. Oh, I'll have to sub in my other r variable as well. So if I sub this in here, you end up getting v over pi r squared times, this ends up being the cube root of pi, cube root of v. There's like a little bit of algebra to do here when I go to solve this. So I end up getting v over the cube root of v times cube root of pi over pi and 1 over r squared. There's a bit of algebra to do on this, but you'll see what ends up happening here is this ends up being v to the 2/3 over pi to the 2/3 times 1 over r squared is going to be, you end up getting pi to the 2/3 over v to the 2/3 here. This all cancels. You end up getting 1. So the ratio of h over r is a 1-to-1 ratio. I substituted in my r value back into here and did my algebra. I end up getting everything canceling off. You get 1 for this one. I won't put this 14 on the test though, but that's the answer. So the idea with 14, to outline it, is I treat it like a normal problem, take my first derivative, solve for r. I got a representation for r, and then I kind of subbed it into my formula. Like I have I have this equation for h, so I did h over r. I just subbed it in, and then you have your algebra here. Just I simplified it a bit, and then I substituted this into here for my r squared. And when you do all your math, everything cancels. You end up getting 1. So that's 14. I won't ask 14 on the test. We didn't spend enough time with the ratio questions, but that's how you do it. Okay, so there's 14. 22. So 22 is 22 is a wire question. So in 22 they give you the length of the, what is 22? So for 22 the length of the wire is 8 meters. It's cut at some length. So this is like some length x, then you have some remainder length 8 minus x. It says one forms a circle and the other forms a square. So I've got a circle out of this and a square out of this. And for number 22, oh no, sorry, that's 21. 22, one forms a rectangle. Sorry, guys. For 22, one forms a rectangle. Okay. And the other is an equilateral triangle. So Eric, with 22, since you're the one who asked 22, you have the same setup. You've got like a wire that's 8 meters long. It's being cut at some length at x, and then you have your remainder length. Creates two shapes. First shape, they tell you in the question, is a rectangle. It says its length is twice its width. So like if I let this be the width, its length is equal to twice the width. So its length would be like 2w. And then the remainder on this side here, I have an equilateral triangle. So this part's easy, right? The area of this shape would be, in this case here, it would be w times 2w. So the area of this would be 2w squared. But the thing here is the total amount of space, the total perimeter I have to use here is the distance around this object, which is equal to the distance from here to here, which is x. So I know that x is my total like perimeter around is x in length, and I know this is w and this is w here, and I have a 2w, 2w. So you're going to end up having 4, 5, 6w. This will be 6w. So the w is equal to x over 6. So therefore I can substitute that into here. So I have this as a function of x is going to be 2 times w is x over 6 squared. So you get 2 times x squared over 36. And the area of this rectangle is x squared over 18. Right, so Eric, is this okay so far? The setup for this one? Anyone else who's on 22 as well, like one of these wire questions? Right, I know the whole perimeter all the way around is x. So I know this is w and this is twice. Okay, so once I have that, that's taken care of. I now have to calculate the area of like this equilateral triangle. Oh, thanks, Malik. That's great. Tell him I said hi. So for this triangle here, if you take a look, because it's equilateral, each chunk is going to be 8 minus x over 3. So at any rate, if you have an equilateral triangle, you know the interior angles of that equilateral triangle. Here, let me draw this bigger for you guys. If you have an equilateral triangle, I know that this is 60 degrees, right? Every angle inside the equilateral triangle must be 60 degrees. I know that this is x 8 minus x over 3, right? Because the whole perimeter is 8 minus x, so each length must be a third of that if it's equilateral. So I want to calculate the area of this, so I need the height. This is my height. I want to calculate my height here. So I know the sine of 60 degrees is going to equal h, which is my opposite, over my hypotenuse, so 8 minus x over 3. So continuing this here, the sine of 60 degrees is root 3 over 2. And that's going to equal h divided by 8 minus x over 3. So continuing this, my h value, if I go to solve for h here, so there's no confusion with the algebra here. Let me show you. This is really over 1. So if you want to isolate for this, you're going to end up getting h is 8 minus x over 3 times root 3 over 2 for my h value. So h is what, 8 minus x root 3 over 6. That ends up being the height here. Right, so like I went ahead, like when I was doing this question with Eric, I went ahead and calculated the area of the rectangle, took care of that. Here we have it. I want the area of this triangle here. So I need the base, I need the height. So I needed the height. So to find the height, I used my sine relationship. I know the sine of 60 is opposite over hypotenuse. So I went ahead and set up my relationship here. Sine of 60 is root 3 over 2. And then I just kind of isolated for my height. So the area of this triangle, the equilateral triangle, is going to be a base, which is, the base is 8 minus x over 3. The height is root 3 over 6 times x minus 8, and the whole thing is divided by 2. Is this good? So therefore the area as a function of x is going to be, let's see, root 3, 8 minus x squared over 36. All right. Is this okay here? Eric, does this make any sense? This will save it. You can kind of go through the idea behind it here. Right, so I have like the area of the rectangle, the area of the equilateral triangle, all the way over here. Oh, yeah, okay. Eric, are you good with how I found the height here? And anyone else who's like on this question? So once I found the height, my area of my triangle is my base. My base is this. So that's going to be the length of one side times the height, which is this, divided by 2. Right? So base times height divided by 2. It's super ugly, but that's how you do it. So then the only thing I did here was I pushed all this together. So this becomes root 3 over 18. And then because it's over 2, you end up multiplying the 18 by 2, which is 36. So I end up getting the area of the triangle is root 3 over 36, right? And then I have 2 of these here, so it becomes the power of 2. So my total area ends up being the sum of both of these, so x squared over 18 plus root 3 over 36 Yes. And that becomes my total area function. Is this okay? So once you have that, then you take your derivative of this thing. So this will be t at a prime at x is what, x over 9 plus root 3 over 18, 8 minus x to the negative 1. If you go ahead and take your derivative, right, I'm going to drop down the 2 and subtract 1, drop down the 2, reduce, and then derive the inside. Look at that. Right, and then I can just set this equal to 0. Good. So I end up getting x over 9 equals 8 minus x root 3 over 18. And now you're just solving for x here. Okay. Right, so now multiply across by 18, you get 2x is root 3, 8 minus x. 2x is 8 root 3 minus root 3x. And I get that value for my x value. I'm getting like 3.71 approximately. Eric, I sense sarcasm. Okay, so that is, what number was that? 22? Okay. Let's continue here. We want to do, what else was there? 22. Someone wanted 32 as well. I got a 32 here. So for 32, they wanted the total surface area of a square-based open-top rectangular box. Okay. So draw yourself a box. It's a square-based box, so I know that I can label this with X and X, and perhaps I can let this be a Y. They tell you that the total surface area of this square-based box is 12. Let's call it centimeters squared. They say unit squared. I'm just gonna label it as centimeters, so centimeters squared. They want you to maximize volume. So you're looking to maximize volume in this question. So if I want to maximize volume in this question, create your volume formula. So the volume of a square base box is going to be x squared times y. And like we usually talk about, you can't maximize two variables. You can only maximize one. So I have to go ahead and maximize one of these variables. So I have to use my constraint to try to eliminate some of this. So I need a representation for the surface area of this box. So the surface area of this box, excuse me, if I look at 32, it's again, they say an open top box. So because it's an open top box, you have the area of the bottom. So the area of the bottom is represented by, my surface area is going to be x squared. And then you have the area of the sides. Well, the area of this side is going to be xy. And every single one of these sides is the same. Like, because it's a square base box, every one of these sides has dimensions of x and y, right? X and y. In the back one as well is like x times y. So there's 4 sides to this, so you're going to add a 4xy. So the surface area of this box is going to be x squared plus 4xy. So I know that that's equal to 12, right? They told me in the question. That's equal to 12 here. So therefore I know that I can isolate for my variable here y. So I know 12 minus x squared is 4xy, and therefore y is 12 minus x squared over 4x. Right, so now I can substitute that into here, and now my function, I can get rid of this y, I can write it as a function all in x. So therefore v at x is going to be x times 12 minus x squared over 4. I can lose one of the variables x. And then now I have my function to take the derivative of. Notice here I have endpoints on this. Like the endpoints are like 12 minus x squared. It has to be positive. Right, so I have v at x. And I have to ensure that this is positive. So 12 minus x squared must be greater than or equal to 0. This is just a quadratic opening downwards. So I know the roots here are, this is like root 12 and negative root 12. So like you have endpoints between here and here. X obviously has to be positive as well. So my endpoints for this are x has to be, really should be greater than 0. Because it can't be 0 anyways. It has to be greater than 0 and less than the root of 12. Right, those are your endpoints here for this one. Is this okay? I don't know, who wanted 32? This would be like the idea with 32. Okay, and then from here, Eric, you take your derivative. For sure, Arj, the domain of this, the idea is like, I just have to make sure, first of all, obviously x has to be greater than 0, because you can't have negative length. And this product must also be greater than 0, so I set this equal to 0. I just made the observation that this is a quadratic, like 12 minus x squared is a quadratic opening downwards. And I want to make sure it's above the x-axis, so I kind of highlighted everywhere that it's above, because you don't want negative values. That happens at plus or minus root of 12. But x has to be greater than 0 anyway, so I'm really interested in this area right here. So that gave me greater than 0 and less than root 12. So this is what, 12x over 4 minus x cubed over 4. So and then you can go ahead and solve this one here. So we end up getting what, 3x squared is 4 equals 3. So I'm getting x is, what is that, 12 over 4, 12 over 3. So plus or minus 2. So I'm getting x is 2 as my critical point. No, Chatyana, the endpoints aren't really useful here. There's nothing that you would have to check. They're just like constraints, like, perhaps you got 2 critical points and 1 is outside of the domain, but 2 is in there. So that should be our answer for this one. Sir, when do you need to make a feasible domain? I can never recommend. Typically, the domains are just a check to make sure you're not making a mistake. The ones where you want to check them are like the question before with the rope question. Your endpoint here was 0 and the other endpoint was 8. You'd have to check both of those with this one as well. So you'd want to check those values. With this one as well, you'd want to check those two numbers. Yeah, anything with distance, like the shore questions, like if you've got an island and like a pipe, you're right. You have the option of going this way, the option of going across, or the option of going between. That would be another one as well. Every note. Oh yeah, I'll post all the notes. I didn't. I know I usually say I'm gonna post them, then I don't. But I'll post the note we did today, and then whatever we do in the chat now, I'll post that as well. But there's 32 that Eric was asking. Okay, I went through Eric's questions. Where are they here? Oh wow, okay. Next on the list was Joanne was asking for 49 and 50. Joanne, you still there? I know it's been a little while. Here's 49. Okay, so Joanne was asking for 49. So 49 is like a ship question. So if you're reading 49, a ship leaves a dock at noon and travels south. Okay, so I've got this dock. I got a ship leaving the dock. It's going south, going 20 kilometers an hour. And then another ship heading east, going 30 kilometers, reaches the same dock. So it's the same sort of setup that we've kind of talked about before. You've got like one ship is going east, right? You've got your north, east, south, and west. So one ship is going south, the other ship is heading due east. And this ship actually, what's going on is it's leaving the dock. And for number 49, it leaves the dock at noon. So this whole thing starts at noon. And then this ship actually takes 3 hours. So I multiplied this by 3. I end up getting 90 kilometers as the boat is initially 90 kilometers away before it reaches the dock. It takes 3 hours to get there. So since it took 3 hours to get there and it was going 30 kilometers an hour, the distance initially was 90 kilometers away. And that means that this boat also must travel for 3 hours, which makes this 60 kilometers away. So what you want to do is, this is when the trip is done. What you want to do is represent this. They want to know at what time are they closest together. Like perhaps they're closest together when this initially starts. So this boat's here and this boat's here. Maybe the 90 kilometers is as close as they get. But as this boat travels this way and this boat gets closer, right, the lengths between them are going to change. And you want to know when are they the closest together. So using the dock as the frame of reference, the initial distance from here to here is 90 minus 30t, right? Every hour that goes by, you're 30 kilometers closer to your destination until 3 hours has elapsed. And then every hour that goes by with this boat, you're actually 20t away. So you kind of have this relationship here, like a right angle triangle is formed because one's going east and one's going south, and one's going towards the dock and one's going away from the dock, but it creates a right angle triangle. And I'm looking to minimize my distance, so I'm looking to minimize d at t, which is the square root of 20t squared plus 90 minus 30t squared. And I want to minimize that, so this ends up being d at t is, Joanne, does this make sense? This will be 400t squared. And what does this end up being? 8100. And then minus 5400t plus 900 t squared. Sure. When the problem starts, the boat is 90 kilometers away. The reason I know that is it took 3 hours for this boat to get to the dock. So when the problem started and I let time start to run, this boat was 90 kilometers away. Every hour that goes by, since it's traveling at 30 kilometers an hour, it's closer to the dock. So for instance, after an hour, this boat must have traveled 30 kilometers. So 90 minus 30 is my remaining distance of 60. After 2 hours, the boat must have traveled 60 kilometers. So therefore 90 minus 30 times 2 is going to be 30, and it's my remaining distance to the dock. And then lastly, when time is 3 hours, 90 minus 3 times 30 is 0. So I'm at the dock, and then time stops. So that's why I have to do this 90 minus 30t business. Because this boat is decreasing its distance to the dock, and this boat is increasing its distance to the dock. Yeah, no problem. So let me just check my math here. So square this out, you get 400t squared. Square the first is good. First times second times 2, I believe that's right. And square the last, that's good. So I just collected things up together. You can take your derivative. So I drop down the half. This all gets pushed to the bottom, which we end up not considering. Right? And then the derivative inside becomes 2600t minus 5400. Right? All of this right here gets pushed to the bottom, and it won't contribute to one of your critical points because it's never going to be 0. So when I set this equal to 0, I really end up just having to solve for the top, which is 2600t minus 5400, and we get our critical point, 54 over 26, which is approximately 2.08 hours. So at around 2.08 hours, number 49, I'll double check this one. Yeah, they got 2.077, so 2.08 hours. Right, so you can like adjust the time, multiply by 60, and change it to minutes. You can find out. But after approximately 2.08 hours, that's when the boats are closest together. That's 49. Okay, there's 49 here. What else we got? 49. Oh, Joanne wanted 52. Oh, Chatiana, that for you only have to point out the endpoints if they're points to consider, like or if you don't find the endpoints, and you miss a critical point perhaps, then you have to double check. So typically, like the wire question has endpoints, like I was talking with Arj earlier. Those are the ones to consider. You want to come up with your constraints really quickly for your volume and surface area. Number 50, did I assign 50? The area of a rectangle is... So number 50, you have a rectangle. Let's draw ourselves a rectangle. And it says the dimensions of the rectangle set the distance from one vertex to the midpoint of the non-adjacent side. Okay. That's the midpoint of the non-adjacent side is minimum. Sure. So Joanne, with number 50 here, you know the area of a rectangle is 4 centimeters squared. So I've got this rectangle drawn. You want to minimize. You want to find the dimensions of the rectangle that minimize the distance from here to here, and this is a midpoint of a non-adjacent side. So I want to minimize this distance. So right away, I labeled here to here x. So this has to be x. So I actually have Pythagorean theorem going on here. So I know the sum of the squares of the legs of the triangle is my distance, square root of the distance. So if I take my square root of my x squared plus y squared, I'm looking to minimize this. So I needed another constraint. Well, my other constraint is right here. So you know that the area of this rectangle is length times width. My length is 2x and my width is y. So I know that's equal to 4. So therefore I know that 2 equals xy. So I can isolate for y here. I get y is 2 over x. And therefore my distance formula that I'm looking to minimize is going to look like this. So I'm looking to minimize this expression. Like, do you want me to solve this one, Joanne? For you? Like, here you take the derivative. Sure. Let me just write this. This is going to be x squared plus 4 over x squared. So this will be x squared plus 4 over x squared. Minus 1/2, and the derivative of the inside is what, 2x, and this will be minus 8 over x cubed. So for this one here, I have to take the derivative of the inside, which the derivative of 2x, or x squared is 2x. The 4 over x squared you can write as 4x to the negative 2. So when I drop down the minus 2, it becomes minus 8, and then it becomes to the power of 3. So now I'm looking to take the derivative here, and yet again, we're not even considering this for my derivative because this will never be 0. So it's not going to be a critical point. So the critical point only exists, your critical point is only going to exist when this is 0. So I'm essentially setting this equal to 0 and solving. So this ends up being equal to, I can multiply across by x cubed. So I get 2x to the 4th minus 8 is 0. Or 2x to the 4 is 8. X to the 4 is 4. I'm getting x as the 4th root of 4 here. For this one, what one is this one? This is 50. Oh, sorry. And then, so there's my x value. I was just trying to see. So x, I got the 4th root of 4. So I'll have to double that because they want the dimension, so it'd be twice that length here for this one. So this will be like 2 to the 4th root of 4. And then the y value, where's the y? Is 2 over the 4th root of 4. Well, let me clean. Oh, this is can be cleaned up. This is 4 is 2 squared to the 4th root. So x is going to equal. Sorry. This is just root 2. This is 2 to the half, which is root 2. Sorry, guys. That x ends up being root 2. That's all it is. So I'm getting that this must be 2 root 2 in length here, like for the 2x's, and then this must be 2 over root 2, which is root 2. So the dimensions are 2 root 2 and root 2, which give you max area. Okay. Yusuf, for the wording of this question, what they say in the question is they tell you that the area of a rectangle is 4 centimeters squared, and they say find what dimensions of the rectangle will minimize the distance from the vertice to the midpoint of the non-adjacent side. So this is the adjacent side, so this is the opposite side, so the midpoint of the opposite side. So I drew a line from a vertice to the opposite side at the midpoint. Because it's the midpoint, these are x apiece. I want to minimize this distance. So the distance equation is going to be the sum of the, x squared plus y squared is your distance squared. So I isolated, took the square root, and then I went ahead and used the fact that the area of this whole rectangle is 4. So if the area of this whole rectangle is 4, this length is 2x and this length is y. So I end up getting like 2 equals xy. So I went ahead and dumped it into here, and then I took my derivative. Yeah, for sure. Yep, yeah, that's it was a confusing one. Yeah, the 4th root of 4 is just root 2, which I didn't see that at first. But there, that gets you your answer. All right. So there's 50. I don't know. I've kind of lost where we're at now. I'm just kind of going back. Malik, yeah, can you do 40? 50. I got number 23 from page 147 from the class textbook. Oh, Maru, the y value, how I got the y value for this question is I know that x is root 2. So I subbed it into here. So I get 2 over root 2, which is just root 2. That's how I got that value. Okay. Oh wait, Ara, do you want the 90? You want the boat question again? Yeah, right here. This boat is going towards the dock, so I have to knock off 30 kilometers every hour. Initially, it's 90 away because they told me it took me 3 hours to get to the dock. So going 30 kilometers an hour, it took me 3 hours to get to the dock. That's why it's 90. So initially I'm 90 kilometers away. Every hour I eat up, I'm 30 kilometers closer. So I have to subtract a factor of 30t every hour. So the first hour it's 90 minus 30, so I'm 60 away, right? And then after that, I'm going to be 30 minus 60, I'm 30 away, right? And we continue from there. Whereas the other boat has the opposite issue. The other boat is moving away from the dock. And every hour, the other boat is 20 kilometers further away from the dock. So it's going to be 20t. So one's going one way, one's going away from the dock, one's going toward the dock, illustrated by this function and this function. Adam, you have to be nice, so I'll kick you out. Alright, should we kick Adam out or no? Let him stay. It's up to you. Okay. All right. Someone wanted page who wanted, what are, there's like a million here. 49 and 50 is done. Oh, Maru, I just saw you. Someone, I'll go back to Maru's question. Maru wanted 21. Someone wanted number 23 from page 147 from the class textbook. I can look at that. Okay, this is 23, page 147. So page 23, page 147, number 23, the base of a rectangle lies along the x-axis. The upper two vertices are on this quadratic. Okay. Oops. So you have yourself a rectangle in this question. Like you've got this rectangle. The base of the rectangle lies along the x-axis. The vertices of this intersect with the following function, y equals k squared minus x squared. So this opens downwards, see? Because your leading coefficient is negative and it's a quadratic. So it's going to look like this. Notice this quadratic is symmetric about the y-axis. So that's what I have here, is this setup. And what they want you to do is find the dimensions that give max area. So the idea here is, okay, it touches right here, this vertice. So the first coordinate is x. This must be k squared minus x squared as the second coordinate, right? Since it's on the parabola, that means the distance from here to here is x, right? Like I'm at the origin, it goes over x, then up k squared minus x squared. So that means that this distance here is x. So I want to maximize the area of this rectangle. The area of this rectangle is going to be the base, which is 2x, right? Length times height, or width. So in this case, k squared minus x squared. So with this question here, whoever had asked it, I want to maximize 2x times k squared minus x squared. So I'm going to distribute this. Is going to be 2k squared x minus 2x cubed. So therefore, a prime at x is my derivative. When you take the derivative of this is a function of x. So the derivative of x is just 1. This just becomes 2k squared minus 6x squared. So I set this equal to 0 and solve. You get 2x cubed minus 6x squared. And I can solve for x. I can solve for x here for this question. So this becomes what? K cubed over 3. And I'm getting x is the square. How do I get k cubed? I think it's k squared. K squared. Oh, this should just be k squared here. Just looked a little messy. So this is k squared. K squared. So I'm getting x is plus or minus k over, I guess, root 3. I don't know who had originally asked this question. Oh, sorry. There's a... All right, sorry, I missed all that messages there. Sorry, guys. I didn't see any of them. All right, a lot of... All right, Adam. All right, Yusuf, Eric, Arj. Okay. Who wanted this one? Is this answered now? I don't know if someone had asked it. This is done now, I'm assuming. All right, Maru, are you there? Do you still want 21 from the Orange Book? Sure. Is Kais here? Does Kais need help? What happened to him? All right, Maru, let's check it out. So 21 from the orange book here. They give you a wire, so same sort of setup. The wire for 21 is 8, so we'll cut it at x. All right, one forms a circle, the other forms a square. Boom, so circle, square. And we want to, in this question for 21, they want minimum and maximum. So with this question here, Maru, just so we have the same algebra, did you start off with a circle first? Just so our algebra lines up. Okay, so therefore, if you start with a circle first, you know the area of this circle is pi r squared. But my r is now x over 2 pi squared, right? So the idea here is I know the total circumference of the circle is x, and I know the equation for the circumference of the circle is 2 pi r. So I isolate it for r, I get r is equal to x over 2 pi. I substitute that into my area formula for a circle, so pi r squared. So this becomes my area formula for the circle is going to be pi times x squared over 4 pi squared, which reduces to become x squared over 4 pi. So this becomes my area of my circle. Now I go to this shape here. Well, this shape, each side is 8 over x divided by 4, right? The total perimeter around this square is 8 minus x. So since it's a square, I have to divide it by 4 because every side's the same length. So this will be 8 minus x over 4 squared. So the area of this square is 8 minus x quantity squared over 16. So for this problem, the total area of this shape is x squared over 4 pi plus 8 minus x squared over 16. And then this is what I want to take the derivative of. So I go ahead and take my derivative. This will be, and you can follow along and let me know if you find your mistake. This will be x over 2 pi plus 8 minus x over 8. Right, drop down the 2 and then derive the inside. So I set that equal to 0. 8. Multiply across by 8 pi. This will be pi times 8 minus x. And then equals 4x. So this is 8 pi minus pi x over 4x. Maru, this making sense? So I get 8 pi is 4 plus pi times x, and x is 8 pi over 4 plus pi. Which, I mean, you got to get that down to a number. I'm getting, I'm getting 3.52 approximately. Oh, okay. So there's 21. Okay, are there any others here? Bansari wants 20, 23, 41, and 44. 20. Oh yeah, the printing question. Printing poster question. Number 20. So this printing questions, you've got a poster contains, in this question, Bansari, they gave you the printing area. And they told me in the, They told me in the questions that the total printing area is 200 centimeters squared. That's the total printing area. They tell you the margins in this question. The top and bottom are 8. So like this is 8, this is 8, and then the sides are 4. And they want the dimensions that give minimum area. So I want to minimize the area of the poster. So with this question here, what you can do is I can let this be x, and I can let this be y. So I know the area, so 200 is equal to x times y. This is my constraint. I want to minimize the total area of the poster itself. They want the smallest poster possible that gives me 200 centimeters squared of printing area. Right, so the idea is obviously this printing area, like I could make it look like this, and it could still, it just has to have, like I can squish this rectangle in various sizes that'll still have 200 centimeters squared of space, still keeping these margins. So you want to see what you can minimize. So what I want to minimize is this length here is going to be x. Right, I'm labeling this as x. I'll label this with an x. And then I'll label this, this is getting a bit messy in here, but I'll label that with a y. So therefore this length here is x plus 4 plus 4. So this will be x plus 8. So this is my x plus 8. And then this here, this length here, will be y plus 16. Y plus 16. And this is my area. This is what I want to minimize. So I want that to be minimum. So with this problem here, I'm looking to minimize it. So you use your constraint here. So in this constraint, I know that y is going to equal 200 over x, and I can sub that in. So therefore, area as a function of x is x plus 8 times 200 over x plus 16. Okay, this was for Bansari. I don't know if Bansari is still there, but this is my area function. And then you distribute it out and solve. Arj, to answer your question, it doesn't really matter. Like, it's easier typically, like, if they give you the printing size, I usually let that be x and y, because you'll find the other way it's messy, but it's not wrong. Like, some people solved it the longer way algebraically. It's not wrong to do it that way. It's just like a little more work. And 8 times 16 is 80 plus 48. Is that 128? Yeah, I mean, you actually can, Arj. It's just like a little bit more algebra to find it. But, you know, if you're writing the test and you're having trouble isolating for the variable, you can probably quickly remember, what if I switch them? But the idea here is by letting your constraint be variables that are easy to isolate for, it makes it easier, because else your constraint would have been like 200 equals x minus 8 times y minus 16. And then you would have seen like, oh, okay, this is going to be a little bit of work to isolate for y here, or x. So that's kind of like the hint with 20. But if you compare 19 and 20, you'll see typically you just want to let the constraint be easy to isolate for. So with the poster questions, just keep that in mind. And you can see 19 and 20 kind of illustrate like the differences between the two. Ion wants, someone wants 40, 51, 53, 40. Did I do 40 already? I think a couple people asked for 40 already. All right, what's 40? Finish this one, sure. So this is 200. I just want to double check my math. This is 1600 over x. 8 times 16 is 128. Okay, and then sounds good, Eric. So now I'll take my derivative. The derivative of 200 is 0. That's gone. This will be what, 16 minus 1600 over x squared. Right? If I take the derivative of this goes away. This is just 16, and this is negative 1600 over x squared. So I'll set this equal to 0 and solve. You get 1600 over x squared is 16. So x squared ends up being, what is that, 100? And when you get nice numbers like this, we're probably on the right track. I'm getting x is 10. As my critical point here, x being 10. Okay, I'm sure that's probably the answer for 20, Yusuf. Okay, who wanted, someone asked for 40s. Whoever wants 40, is that still a question people want? I'll get to 39 and 41 too, I'm sure. Does anyone need 40? Oh, yeah. Yeah, you know what? The domain for this one, you can look at your area function. Okay, sure, I'll do 40. So if you look at the area function, you know that x has to be greater than 0. And other than that, I mean, you can... There's not like a meaningful endpoint on this. You can have x is greater than negative 8, but you already knew x is greater than 0, so it's kind of taken care of with your area function. So there's not really an endpoint other than x is greater than 0. Number 40 here. Okay, this is a cost of a power line question. So you've got an island. It's 4 kilometers from shore. And then down the island, a power station is 8 kilometers away. We've got a power station here. So similar setup to what we've done. And underwater is, what does it say? Is 3 times more expensive than ground. So you've got the same idea. Like you're either you don't know where you should go. Sorry, guys. Okay. So you don't know where you should go. Like the idea here is either I like go completely from here to here, but it's going to be 3 times more expensive, but it's the least amount of distance, or I take the longest route and minimize the amount of time I spend underwater because it's the most expensive route, or perhaps it's a balance of both. So once you have this here, you calculate your distance formula. So the distance of this line is going to be 16 plus x squared. That's going to be the distance of that line here, and then the distance here is going to be 8 minus x. So my total distance traveled is the root of 16 plus x squared plus 8 minus x. Now if it costed the same underwater as above ground, the answer would be from here to here. Right? Because then you're minimizing cost, because your cost and distance are the same here. But now they're not. Because it's 3 times more expensive going this route here, I have to take this number and put a 3 in front. So now I've weighted my cost function 3 times heavier or more expensive underwater. So this becomes the function that I'm going to take my derivative of. And this is a question with endpoints. The endpoints of this question are 0, 0, or 8. 0 represents the idea of if x is 0, then I'm going to go from here to here to get to the power line. If x is 8, I'm going to go from here to here. And now the derivative, the critical point here will be like the value in between. So this will be just my derivative. So the endpoint here is I'm cutting this at a length, I'm going to the shore at a length x. So if I let x be 0, I'm going to go from here to here. Right? X can't be anything less than 0, and x can't be anything more than 8. Because if I cut this at a length of 8, I'm going right to the end. You're obviously not going to go all the way to here and over. Right? That's not part of your solution, is to go further than the power plant and then going backwards. So the absolute farthest you can go is directly to the power plant, completely underwater, or go across and then over. Good. Okay. So I'll take my derivative. So this will be what? 3 over 2, 16 plus x squared to the minus 1/2. And then the derivative of the inside is 2x. And then plus negative 1. The derivative of 8 minus x is negative 1. And this, I dropped down the half, subtracted 1, and derivative the inside. So now set this equal to 0, and I can solve this. The 2's will cancel. I get, 3x over the root of 16 plus x squared minus 1. And you're just solving for this question. I can look up 51 for you, Daniel, and then I get x squared plus 16 equals 3x. Square both sides, and you just solve a radical equation. So square both sides, you get 9x squared. 16 is 8x squared. I'm getting x squared is 2. I'm getting root 2 for x. Turns out that x is root 2, and then you have to check your endpoints. I'll let you guys sort of finish this one up to check the endpoints. So I have your cost function is going to be t at d at 0, and then t at d at 8, and then t at d at root 2. And those are like your 3 costs to look up with this question. Right? Set up pretty good? Okay, Dan, you wanted 51? Sure. Hey, quickly, Maru, with the velocity question. It's like the exact same question, except for like, I think this was 3 kilometers and 5 kilometers. So I wanted to, I instead of like the thing of importance being money, like minimizing cost, we want to minimize time. So to minimize time, you take distance divided by speed. So if this was my distance, I divide that by 3 kilometers an hour. It gives me how much time it took me to go from here to here. And then likewise take the distance divided by 5 in that case, and that gives me the time. So then you're minimizing time. That's the only adjustment with that question. But I'll let me go through 51. If that doesn't make sense, I can take a look at it. But for 51 here, you've got like this line crosses through the point 1, 1. I have a x-intercept. I can label that x and 0. I have a y-intercept. I can label that 0 and b. I'm going to let b be the equation of this line is y equals mx plus b. Right, I'll let that be y equals mx plus b. So I want to minimize this distance. So the distance here, if I just go to my distance equation, the distance between this line is going to be just x squared plus b squared. is the distance between this line, right? It's going to be change in your x squared plus change in my y squared. So you end up just getting square root of x squared plus b squared. Ends up being my distance equation. And I need to get rid of one of these variables. So I haven't used my slope equation yet. So you'll notice that if I do my change in my y over the change in my x, that's equal to slope, which in this case is m. So I know that, like, I need another relationship here. So I know a couple of things. I know the change in my y over change in my x, right? So like y2 minus y1, y2 minus y1 over x2 minus x1 is equal to m, my slope. So I know that negative b over x equals m. And I also know that 1, 1 is a point on the line. So I can sub this point into the equation. I know that 1 equals m plus b. So the idea here is I have, like, there's a lot of information on this page, but I've got this and I've got this. And I just want my function, I want this to be a function in one variable. So I know that, what do I know? I know x is going to be, like, from this equation, Daniel, I know that x is going to be negative b over m. And I know from this equation that b, if I go over this equation up here, I know that b is 1 minus m. So I can get rid of this b, and I can change it to a 1 minus m over m, which is m minus 1 over m. So I know that x equals m minus 1 over m. And I also know that I can get rid of the b here. So I can rewrite this distance equation as the square root of m minus 1 over m squared plus my b value is 1 minus m squared. So I kind of piecing this together in little chunks, I got this expression now as a function in one variable, which is what I'm looking to minimize. I know my distance equation is just this. I want to minimize this. So I guess we could clean this up a bit. This isn't a distance equation, R. This is just the equation for slope. This is just like y2 minus y1 over x2 minus x1. So to take the derivative of this, trying to think of the easiest way, I could write this as 1 minus 1 over m squared plus 1 minus, like that. So I don't have to do the quotient rule. So this will be equal to, so again, you go to take the derivative of this one. Again, that'll get completely discarded. We're not going to have to deal with that. That'll just go to the bottom, and it won't be factored into my critical point. But then I have to take the derivative of the inside. And that's what's important here. So this would be 2 right, so there's, people aren't lost here. I took the derivative of this expression. I dropped down the 2, subtracted 1, and the derivative of the inside is going to be equal to this. You know, the bottom doesn't matter because to make the bottom, like, essentially, Daniel, this is the bottom. So when will the bottom ever be 0? The bottom would be 0 if either m equals 1. So if m equals 1, then if m equals 1, then my y-intercept here is going to be 0. So it's like a flat line, right? So it doesn't cross through this point. So like m being 1 gives you a y-intercept of 0, so the question falls apart. You don't cross through the point that was intended, right? So then the only way that this can be 0 is if m equals 1, and that's not possible because if m equals 1, you won't cross through the point 1, 1. So that means only the top is of concern here, so I just want to solve for this and find out when the heck is this 0. So it's like a little messy, but we can do it. So this will be 2 over m squared times 1 minus 1 over m minus 2 times 1 minus m is 0. So I'll distribute this. I get 2 over m squared minus 2 over m cubed and minus 2 plus 2m equals 0. Okay. Not so nice. That's good, that's good, that's good, that's good. Okay, I'll just multiply across by m cubed. You get 2. If I multiply across by m cubed, I get 2m minus 2 minus 2m cubed plus 2m to the 4th is 0. I really should divide across by 2, eh? I should have done that earlier. Sloppy. So what do I get here? M minus 1. And then take out plus m cubed. I get m minus 1 equals 0. So I end up getting here 1 plus m, 1 minus m plus m squared, m minus 1 equals 0. And end up getting m. You end up getting m as plus or minus 1. 1 we kick out. So I'm just getting m as negative 1 here. Yeah, but don't rest assured this is not one I would put on the test. But I mean, you guys ask it. So the answer actually is m equals minus 1. But this is the answer. Just so you know, this is the answer. But I'm not putting this on the test. But I want to. People ask it. I still think like you can learn something from it. But I'm not going to put something like this one. It's like a not what I was looking to do. Like all the other ones that have been asked are totally fine. Just that one is a little, and this one here, the h over r one, it's just wasn't something that we focused on enough that I felt like it's been covered enough. And this one, there's a little bit too much messing around with to get it, but it's a nice question. M equals minus 1, then you can solve. Yep. So I did, the algebra was a little bit messy, Daniel. Then I had to use my sum of cubes formula. And you get two values. One is 1, which we said was not possible. And the other is minus 1. If m equals minus 1, then you can solve for b. B ends up being 2. And we're done. No ratio questions? Oh, okay, yeah, for sure, Arj. That's going to do that. Eric wants 39 and 41. So, Eric, 39 was the one I had helped. Maru was just asking. It's the exact same question as this one here. The only difference with 39 is you're dividing this length by 3. Whatever this length is in the question, you just divide it by 3. So it's like over 3 and then over 5. Here, I'll just do 39 since it's asking. Ion wants 53. Here, let's help Ion out. I know he wasn't at class today. Skipping class. So 53, Ion, you've got it. It's actually much like the one someone asked from the class textbook. It's like the one someone asked from the class textbook was a generalized version of this, but you have the same setup except for it's an isosceles triangle. So you have an isosceles triangle, and mine's all messed up here. Okay, I have an isosceles triangle, and it says, oh, one of the vertices at the origin. We gotta flip this thing. So Ion, the setup has to look like this. You see? This has one vertice at the origin, and the base of the triangle, which is going to be this length here, is parallel to the x-axis, and then its vertices cross through, again, just like that question we did earlier, 12 minus x squared. So you want to minimize the area of this this is an isosceles triangle. So this point right here is x 12 minus x squared. So the area of this triangle is the base, which the base is the distance from here to here. This is x and this is x, so the base is going to be 2x. The height is going to be 12 minus x squared, and then you're dividing by 2. So my area function, Ion, is going to be x times 12 minus x squared. And that's what you're looking to maximize. Right, so if you take your derivative, so if you solve this, you end up getting x is equal to plus or minus 2. For your x value, that's just illustrated by the other side, like negative 2 and positive 2, right? But the x value is 2 that you're looking for. Okay, notice this question is the exact same. It's like a specific question to the one that we generalized. I can't remember who asked it. It's right here, this one. See, if you change the equation that Ion just asked was y equals 12 minus x squared. And we did, in this question, we did k squared minus x squared. So that implies that k is equal to the root of 12. So if I put a root of 12 into my answer, see, here's the answer we got. If I put a root of 12 into this, it's going to be the root of 12 over the root of 3, which is exactly plus or minus 2. You see? So this is like a general, this question is, even though it's a different shape, it still gave the same formula, the same answer. See? You still get plus or minus 2 for that one. 53. Oh, okay. I'll keep that into consideration, Eric, if you're passionate for the island question. And what was the other question you were passionate about? Oh, the boat question, yes. Boats and islands, got it. Anything else I can help you guys with? Oh, so, Haneen, to answer your question with the domain, only where the endpoints are useful. So like the wire questions, like where the endpoints are like can be actually give you non-zero values. I'd like you to consider those if you're still there, Haneen. 41, sure, 41. So for 41, you have two vertical posts that are 7 meters apart are of length 3 and 4. So you got like a vertical post 3, 4. This is 7 meters apart. This is 3. This is 4. And what they say in number 41 is a wire is run from the top of a post and reaches the ground and goes back to the top of the other post. So it's kind of like boom, boom. Find the minimum length of the wire. So this is kind of like the wire question a bit, because this is x and this is 7 minus x, and you're looking to minimize this length here. You guys see that? So this is 41. So again, you break this up. I know this length here is the square root of 9 plus x squared. And I know this length here is the square root of what, 16 plus 7 minus x squared? So I know the total length of this wire is going to be x squared plus 9 plus the square root of 16 plus 7 minus x squared. So I'm looking to minimize that. So I go take my derivative at x is 1/2 x squared plus 9 minus 1/2 times 2x, and then take the derivative of the second portion. And this is going to be 2 times 7 minus x to the negative 1. Right, so I went ahead and took my derivative of this question. Eric, are you good with the setup here? The derivative is definitely messy, so you, I dropped down the half here, subtract 1, drove the inside, did the same thing here, and now you're solving this equation. So I'll let you solve it from here, Eric. Well, if you want, I can continue it. But. So I get here, what, 7 minus x over x squared plus 9. All right, sorry, a little computational. Let's see, here we go. So I just killed the fractions, multiply across, and then you're solving this. So I guess we're going to have to square this thing. What is this? 7 minus x squared plus 9 equals x squared times 16 plus 7 minus x squared. And then you would continue to solve this one. Don't know how bad it is to solve here. Oh, actually, the math comes out kind of nice. To solve this one here, if I distribute this, you get x squared times 7 minus x squared. Oh, sorry guys, plus 9 times 7 minus x squared equals 16x squared plus x squared times 7 minus x squared. So these end up canceling here and here. See, they end up coming out to be the same, which is nice. So now you're just solving this here, this part. I don't know if anyone saw this. You could do a difference of squares on this. And then you end up getting here, what, 3, 7 minus x minus 4x. And then 3, 7 minus x plus 4x equals 0. 21 minus 7x, 21 plus x. So I end up getting here 3 and negative 21. That's no good. So I got my answer was 3 for this one. What number was this beastly question? What was this? 41. This is 41. The answer is 3. So the algebra is a bit messy here, as you saw, but I got cancellation here. I brought everything to one side. I just did a difference of squares here to make the algebra a little bit easier, and I got x as 3. But that's not an easy one. Are there any other questions? Ion, you wanted 125.8D? You having trouble understanding the theory of question 27? Sure. The idea with 27 is you have like a rectangle and you have like a semicircle here. And in 27, the rectangle part emits twice, like there's twice the amount of light coming through here. So the area, like if you calculate the area of this shape, the area of the shape is broken up into area of the semicircle plus the area of the rectangle, right? If light shined through equally in the circle portion as the rectangle portion, then this would just be an area question, and maximizing the area would yield maximum light. But because twice the amount of light is coming through the rectangular portion, like I'm getting twice as much light coming through the rectangular portion here, I can't let the areas be equal. I have to put a higher weighting on the rectangle. So the amount of light, or you can think of it as I've doubled the area or something like that. I'm making twice as much area or twice as much light coming through the rectangle, but because it's true, twice as much light comes through. So by putting a 2 in front, I'm weighting this shape as being twice as important. And what we're deeming as importance in this question is light. If the cost of this, if this shape was twice as expensive, you would just put a 2 in front. Right? So that's the idea with 27, is you just have to put like a factor of 2. I'm using the 2 to represent twice as much light. but you can use the 2 to represent twice as amount of cost, because the amount of the area, the cost is a factor of the area, and the light is also a factor of the area. They're both proportional to your area. So this is like an area question, just tacking on the like a heavier weight onto the rectangle. Does that make sense? Like if they said in the question that the semicircle emits 3 times as much light, then you would eliminate this and then just put like a 3 here and do your question. Seniors. 47. Yeah, so 47, I think we started it a while ago, all the way. Someone had... Oh, no, I guess we didn't. Here, let's do 47. Okay, so for 47 here, you have an open top rectangular box. So you got yourself your open top rectangular box. Has a fixed volume of 250 cubic centimeters. That's fixed. It says the width of the box is 5. Okay, that's 5. And I'll let this be X. It's a rectangular box, so this is X, and I'll let this be Y. I want to minimize cost. So the cost of this box, it's again, this is an open top box, so the cost of the box is the bottom. So the area of the bottom is 5x, but the bottom costs for 47, the bottom costs $2 per square centimeter, so I'm going to put a 2 in front to represent that. Plus the sides are different. I've got the side here is going to be xy, and how many, and there's 2 sides to that, so it'll be plus 2xy. Right, this is 2xy right here and here. But what's the cost of the sides? They tell me in the question the cost of the sides is $1, so I don't have to multiply by anything. And then the cost of the front would be all of this, is the cost of the front is going to be 5 times y. And there's 2 of those. So plus 2 times 5 times y. So the cost of this box is 10x plus 2xy plus 10y. There's the cost of the box. And I know the volume of this box is 250, and it's equal to 5xy. Right, so therefore, 50 equals xy and I mean you can make this quite simple. This is like your cost function as a function of x. I've got 10x plus 2. I know x times y is 50, so I can get rid of the xy and put a 50 plus the 10. I can replace the y with the 50 over x. So you can make it fairly simple, your cost function. You notice I did something maybe we haven't done before. I saw x times y is 50, so I actually got rid of the x and y and changed it to a 50, and then I isolated for y here, and I wrote y as 50 over x, and I dumped it in there. So now I have my cost function. C at x is 10x plus 100 plus 500 over x, and then I can take my derivative. So this is c prime at x is 10 minus 500 over x squared. And you can set this equal to 0 and solve. So I get 10 equals 500 over x squared. X squared is 50. And I get x is, what is that, 5 root 2 for my x value. Okay, who wanted, so 500 over x is the same thing as writing 500 x to the negative 1. So when I take the derivative, I drop it down and subtract 1, you end up getting this here. I got 5 root 2 for 47. Okay. So I think that's it for me. I'll save all these for you guys under D2L. So each section, I'll save all these for you. And I'll save these under notes. I'll just put April 2nd. And I'll save these for you guys so you can check out the notes for April 2nd. This will have the class notes today plus more solutions. And that is it. Yeah, Chatiana, unless you want to write during your spare if you have 5-7 off. Because, you know, the next day will be noisy in class. Yeah, Eric, I'm going to post them right now. Yeah, but yeah, no, for sure. Right. If you have Euclid, write Euclid. You know, it's not a big deal. You just write the next day. No, 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 you can't. No, you can't call an absence. No, definitely not. Yeah, just write the next day. It's fine. Okay. I'll post these notes for you guys. Don't worry. So go through all the big questions we've done. And yes, I will preach. But bedtime for me. So this is it. This stream will save. You guys can review it if you need to. And like I said, I'll post all of these notes here under April 2nd under the homework tab for both sections. So good luck, guys, tomorrow. I'm sure you'll be fine. All right. All right, guys. I'll see ya. Yeah, probably a good idea you guys go through a bunch of these. All right, see ya. Bye.